This is a fairly simple example of congruent segments. The question here is find WX. That's the length from W to X. That's part of a whole segment from W to Y. Now these marks right here and right here indicate that those two segments have the same length. It's a mark for congruent. Congruent means same shape, same size. In the case of a line segment, it means that they have the same length. That means here we have two parts that add up to 6, and those two parts are the same length. Well, common sense tells you that each of these should be 3 centimeters. Now let's look at one that's a little more complicated. Here I have a triangle XYZ, and I have two congruent marks on that triangle here and here. That means that this side is the same length as this side. We need to find or figure out whether segment XY, which is this side right here, is congruent to segment YZ, which is the bottom piece right here. There is no congruent mark on here. In order to check this, I'm going to have to be able to find X. Now, what you can do when you have congruent marks, since these are the same length, that means that this expression should be equal to this expression. In other words, they would be the same number if you knew what X was. So that's exactly what we're going to do. We're going to take those two expressions and set them equal to each other and find X. So 3x plus 5 has to be equal to 5x minus 1. Now I have to solve this equation for x. When I find x, then I can substitute back in and see if the two sides that I'm curious about are actually the same length. Now both sides of the equal sign, both expressions are as simple as they can get. They each have one term that has an x and one term without. So here's one term with an x and one term without. So I can't actually add those together because they're not like terms. So what I'll have to do is get all my x's on one side and all my numbers on the other side of the equal sign. So I'm going to start out by subtracting 5 from both sides, or I could start out by getting my x's together. Actually, let's start out with subtracting 3x, and we'll get all our x's on the right side of the equal sign. If I subtract 3x from both sides, it goes away on the left and leaves me with 2x on the right. I haven't done anything with the numbers yet, so the numbers stay where they are. Now, I've got a term that's just a number on the left side of the equal sign. On the right side, I have a term with an x and a number. I want to get rid of this negative 1. And to do that, I'm going to add 1 to both sides. That eliminates the minus 1 on the right and leaves me with 6 on the left. So I have 6 equals 2x. Now, the last step to each equation that you do, whenever you get rid of the number that's in front of the variable, in other words, I want to get rid of the 2 that's in front of the x, I'm going to divide, because 2x means 2 times x. So divide both sides by 2. That eliminates just the 2 on the right side, leaving me with just x. Now it doesn't matter if x ends up on the right or the left, it's meaningless. 6 divided by 2 is 3. So x is equal to 3. So now what I can do is I can take this 3 and substitute it in each expression on the two sides that I'm curious about where the x is, to see if these are actually the same number. So for segment XY, which is this segment right here, I'm going to put 3 in for the x. So 3, now 3x means 3 times x. Or 3 times 3 in this case. That is equal to 9 plus 5, which is 14. And then substitute the 3 in segment YZ. So 9x over 2 is my expression. I want to put the 3 in for the x. 9 times 3 is 27. Divided by 2 is 13.5. So here we have our two answers, 14 and 13.5. Are these segments congruent? The answer is no, they are not. So not congruent. Then the symbol for congruent is an equal sign with a tilde over the top.